All right, so we are two speakers today representing the same group. It's called ABL Group. And we've got different companies within the group. ABL France, represented by myself, and INNOSEA. So that's the agenda proposed today. Some key figures about the group. I try to be fast. Then the engineer work we do, and the R&D work presented by Mattias. Some lessons learned during the installation phases, and then eventually conclusion and some questions. The idea is to go through some lessons learned or some topics we've identified on the number of projects we've experienced so far. That's our group, ABL, more than 1,500 people, only doing engineering and consultancy worldwide, with a number of companies specialized in renewable. So this is the key sector we are working, originally the oil and gas, maritime, and the focus, I think, today and in this world nowadays is the renewable, where most of our experience is on wind offshore, fixed, bottom fixed and floating, but also other projects, tidal, floating solar, hydrogen, and other topic. What's interesting to see is the wind capacity. It's not the wind capacity of project installed, because it's not the case as of today, but it's the wind capacity in terms of projects we are working, which potentially will get to this value. Another key picture with some other key capacity, 150 gigawatts, as I said, and numerous floating projects as well. Not all installed, but some are in R&D phase, some are in development, and some has been installed. So it's interesting to see that we can have within the group a number of experiences, a number of track record, working with a number of developers, contractors, and so on. If we zoom in the French map, we could see that we've been involved in all the projects offshore, doing quite a number of hours, of days. It ranged from consulting engineering, mainly at the beginning of the project, during the bidding phase for the developers, or during the development of the concept of the project. Then we've got the owner engineering, which is working with the developers mainly, or the main T&I contractor during the project development. Looking at the engineering, looking at their subcontractor strategy, looking at the risk, looking at the end phase as well, how we can anticipate the issue during the installation, during the decommissioning, during the production and maintenance, and also involving a number of client representation offshore and marine warranty. So for people who doesn't know what is marine warranty, is working as a third party for the developers mainly, but on behalf of the insurance. Because if there is an incident, there is an insurance system in place which imposed maritime experts to warrant that the procedure, engineering, and operation are safe. These figures here show that some people may say that in France it's just the beginning, and it is the case. But a company like us has worked more than 2,800 days on site, so in the harbor, offshore, in the yard. So that's French people working in French project on site, with obviously quite important feedback. 50 people is not true anymore, it's more than 60 people between the French office in Paris and in Nantes. And yeah, a core business as well is ship inspection, vessel inspection, which is also quite interesting for some of the developers as well. I don't know if you want to get some... No, you're good? Okay, let's go to the engineering bit.
Okay, so I'm going to present 3 topics where we're involved regarding engineering. So the first topic is related to geoscience. So we have a group of about 35 people in the group involved on this topic. And where we work on this is from the early stages, we define the specifications for the surveys to be performed. We'll support the developer to select the contractor, follow up the campaign. So we don't do the measures themselves, but we provide the client reps on board to follow up. And we'll do the assessment of the data, the accuracy of the data, and just ensure the information is there to perform the future design activities. So from this site management, we can create a report, a ground model, and this will be the basis for all the equipments which will be sitting on the sea ground, so the foundations, the anchors potentially. And related to this overall geoscience activities, there are other studies we do on a regular basis. So it's related to some anchor penetration analysis, core protection for the foundation. One large activity we have currently is for export cables, where the geoscience is at the core of the engineering. And in particular, it's regarding the cable burial, how to protect it with respect to the fishing activities, for example. And around that, this geoscience team also supports the foundation design. And we are also involved on seismic risk assessments, which is not, let's say, relevant to France, but this is an activity we do elsewhere. Another activity we have developed and we're working on actively in France is related to the cable engineering. So there's installation engineering and design engineering. So related to the installation engineering, there's again this cable barrier risk assessment. This is a methodology developed by Carbon Trust. This is a UK entity which has defined the basis for this specific assessment. And this is quite important because it defines how deep you will bury your cable and how much protection it needs. So it will define all your installation means, vessels and associated equipments. Then we do what we call more in-place analysis. So this is related to the dynamic cables, which will connect the floaters for floating wind to the offshore substation or up to shore, let's say. And this dynamic cable has some specificities. You need to account for the floater motions, the wave, current, marine growth conditions. So on this we are working, let's say, worldwide up to detailed design. And in France we are supporting developers to perform these activities to de-risk the tender. The third topic I will mention, we can go to the next one. Yeah. So the first topic, which is at the core of what we do here in France in our office in Nantes, it's the foundation engineering design, where we perform what's called the integrated design process. So this is coupling the turbine to the let's say the turbine loads, to the wave loads, and the impact on the foundation, which can be bottom fixed or floating. This is where we have developed strong expertise now, and we are involved on some of the tenders here in France, and also up to field level, let's say, worldwide. During this, from a foundation perspective, we look at different concepts. So there's monopile, jackets, gravity-based, and also all the floating foundations, which I guess you know there are many out there these days. And where expertise is, let's say, is the interface with respect to the turbine, the associated tools, aeroelastic and structural tools. And a new activity we're developing now. So these first two steps, foundation design and integrated load assessment, help to design the foundation, to provide the loads to all the sub-equipment. And what we're now developing, and what we hope to develop in France particularly, is the fatigue lifetime monitoring. So the first two steps have validated the design, but what you want to know is, can I extend my design, for example? So based on the actual environmental conditions, you reassess your model, and you can then define if you're performing well, and even if you could extend the use of your equipment. And that's it.
Okay, thank you, Mattias. So you've seen that we can cover engineering at R&D and concept design, but also during T&I phases and eventually during the project, the production phase. So that's quite complete. We rely on maybe more than 200 people engineering worldwide. So yeah, we have the capacity. We are not expert in all the field. It's not one person expert in all the field. It's different teams expert in one particular topic, which means that we cannot do. It's not one person doing everything. Just to confirm. So how does it work when we talk about offshore operation? So what's interesting is that there are some differences between these two pictures. Obviously, we can see one is floating and one is fixed, but there are also something which bring them together. It's the first turbines in the French waters. The first floating wind turbine in the French water, floating, and the first fixed. And they are offshore Saint-Nazaire. Here, when we see a floating or a fixed wind turbine, we see just the part from outside the water. But in reality, there is a foundation or there is an anchoring system. There is a cable connected to it. So there is a number of things that needs to be installed and protected subsea. And all these aspects were involved, and we are trying to ensure the installation is as safe as possible. So we said bottom fix. We work on commercial project, on demonstration, on R&D. We work on interconnectors to connect the different countries together to supply electricity. We work worldwide, but obviously mainly in terms of installation in France and Europe. We cover a number of services, I already mentioned it, and a number of operation. And in the next slide, I'm going to show you something we do and the operation we approve offshore. So that's a project of Saint-Nazaire when we worked for the developer, and this is a focus on the substation. So substation is divided between a jacket, a foundation, and the top side, the OSS. And there is a number of engineering prepared to arrive to that stage, including all the weather assessment in order to load, to transport, and to install. There's question. I see some naval architects in the room, so there is also a ballast stability assessment. But eventually, when the situation is safe, it's going offshore. And then at one point, there is a go-no-go decision to lift this equipment and to put them in the right location. So this is all these parameters. We participate to go-no-go meeting, and we validate with the client, the developer, is it safe to proceed or not, and try obviously to have a backup plan in case of incident or near misses. So that's the FloatGen project, the first floating wind turbine in France, where you could see the different, let's say, phase of the construction and the installation. It's a concrete hull, which is with a moon pool. You see it here. After you see the integration of the different towers and the nacelle and the blades. Then after you see the transportation with the tug of here, the mooring line installation and the hookup with the umbilical. So just for one turbine, it's still a quite complex operation. And more recently, we've been involved on cable. Cable is almost 50% of what we do. So cable is because it's involved in all the wind farms with interior cable, export cable, and also, as I said, interconnection between countries, which is growing. And yes, a strong expertise for the installation of cable, and especially for the integration or pull-in to the substation, where you have an interface, obviously, between the cable company, the cable project, and the OSS project. And you have to work in close vicinity between the two assets. So you can imagine a number of risks and discussion with all the parties. So we're still good on the schedule. apart of the technical aspect or technical, sometimes lesson learned we can get on specific project, we try to give a broad approach on other things we've seen generally on different projects worldwide, not only in France. We see that geotech, geophy, UXO survey analysis is sometimes not done to the detail it should be done. And during the operation offshore, if there is a relocation of an asset, or if the soil is not exactly as it was analyzed, you can have some problem to put your foundation, to protect your cable, to put your jacob in the location. So this is something which eventually creates delays in the project. The French soil is not sometimes as soft as maybe in the North Sea, so it's even more true in the French waters. Logistic-wise, we've seen that in France it was the first projects, and yeah, it's not been always as per plan. There's been a number of strikes. As you know, France is quite the world champion in this area. But yes, working, I think a lesson learned is working with local companies, at least French companies, international companies with a base in France is a solution to make sure the project can move forward. Eventually, not during the strike, but at least when the strike is off, we can resume ASAP. What we've noted is the offshore standard for operation is quite known by the main developer, the main contractor, but for a smaller scale project, it's not fully known, it's not understood properly, and usually when we work as marine warranty surveyor, the consequences of not validating an operation is not well understood. So there is usually some contractor will say we can proceed because we think it's safe. No. If there is an insurance in place, the marine warranty surveyor needs to approve as per the offshore standard. We put the NVGL, but it could be others. This one is quite famous. But that's something which, with smaller projects, we see a progress to make. Knowledge of the French market is very important, especially there are a number of players. We talk about the dockers, but you've got the Préfecture Maritime, you've got different HSE validation to get prior to do an offshore operation, which is something we've experienced with a number of developers. And even if sometimes some developers are bidding on projects, it's far from them. They say, oh, we'll worry in the near future or later eventually. This is something that, yeah, we've experienced. We know it's not very easy. We are not experts in all these topics, but we've helped our client developer to go through this hurdle. So this is something to have in mind. So as a conclusion, it's maybe something a bit repetitive, but yeah, a number of players, number of interfaces, and sometimes the gap is not very well known. Who is in charge of what? Who's got the last decision on something? For example, at the interface between an OSS and a cable, obviously some equipment will be from the cable manufacturer put on the OSS. For example, a pulling winch. Yeah, who decide where is the pulling winch? What is the clearance on the different deck? So it could lead to a number of contractual discussions, which if it's not thought at the beginning, you cannot do your operation offshore properly. As I said, a number of parties involved, including third party, fishermen, French authorities, which means that everybody has sometimes a different opinion, protects their interest. So early discussion, and I would say having people competent in their area perspective is very important. Because when you're not competent, you will always go to the conservative assumption. And if everybody takes a conservative assumption, you don't do the project. Second point is, yeah, I try to do a bit of commercial speech as well, is, yeah, we've been involved in a number of projects worldwide. Oil and gas at the beginning, 45 years ago. Renewable now, 20 years ago. So it is true that we have seen a number of projects, a number of installations, a number of things which is working, others not working very well. So this is something, obviously, we want to use for the French project, for the international project, but myself, as a French director of the company, yeah, something to use in France. And it's not only during the installation, it's an early stage. This needs to be taken into account. A bit of money at the beginning will save a lot eventually in the end. And finally, yeah, expertise of companies in key. Even if it's a minor scope, get the right companies to do it. Otherwise, you will waste time and money. Survey and engineering phases, usually it's something we know it's important, but even now we don't, I think, spend enough time to consider this part. And we need to plan for backup in terms of if the installation is going wrong, what do we do? If, for example, we've got a corridor for UXO, and we need to reroute or to put a jackup outside this UXO corridor, what do we do? Is there a system in place to easily extend this corridor? Or we have we've seen in the past. So what do we do if it's outside of what we've defined at the beginning? Yes, and yeah, if there is an incident, a repair, are we geared to repair rapidly offshore, or do we need to mobilize a vessel north of Norway to come and repair the item? I think that's the end of the discussion, unless you want to add something. But thank you for your attention. I hope it was clear. But if you have any question, it's a time, or you can go to our booths later today.
Mm-hmm.